Hey everyone, welcome back. This is episode 2 of my PLC Programming with Structured Text video series. Basically, in the last episode, I talked about IEC 61131-3, why it needed to be standardized, and what some of the programming languages were. So now we need to jump in and set up our PLC. I also mentioned in the last video that sometimes people who want to learn PLC programming will ask what sort of hardware they should buy to get started and things like that. And unless you're blessed with a university lab full of hardware to learn on, typically my answer is just don't buy any. Use a soft PLC. So a soft PLC is something that basically runs on top of a computer, like a normal x86 processor computer. Um, and allows for real-time control and field buses and all that. So it is a legitimate thing in the industry. People are using it. So typically when you think of a PLC, stepping back a tiny bit, a PLC is basically just it's more or less a microcontroller or a system that executes decisions of code. So you've got inputs on one side, outputs on the other, and your inputs could be a switch or a button or a part sensor or a temperature sensor or anything like that. Your code makes decisions based on those values and it activates output. So an output can be the position of a servo motor or extending or retracting a cylinder, a pneumatic cylinder, or a light, or pretty much anything else could be used as an output. So code sits in the middle and the PLC runs that code, and your logic is what determines what happens with it. So basically, I'm going to be using TwinCAT 3 here. This is made by a German company called Beckhoff. So what they've done is put a real-time kernel inside Windows that runs as a really high priority sort of a driver that preempts all the Windows functions, and it sort of gives Windows its own ability to run. It's pretty crazy stuff, but it's tried and true and it works pretty well. So basically, if you download the engineering runtime here, extended automation runtime, or actually, sorry, engineering is the one you really want. XAE. So engineering would be the development environment. Runtime is just the runtime. So go ahead and grab that. You'll have to fill out a little bit of stuff, but it's all completely free, and they don't hound you or anything like that. So install that, and it will take over your computer a little bit. It'll run that kernel driver and everything, but it more or less stays out of your way. It's not too bad. So I'm going to start a new project here. This is inside the Visual Studio shell here that TwinCAT uses. The good news is this IDE is used by a whole bunch of people, so you get the benefit of every Windows programmer using this same IDE. So they've made it pretty good, especially compared to what it used to be. Additionally, it runs on 64-bit systems now, the actual TwinCAT runtime, which is a huge improvement because we used to have to always run in virtual machines and stuff like that. So first thing I'm going to do is make a new project. So I'm going to call it EP2, and I'm going to cancel this source control because we're not using that for this tutorial. And then you get this blank project here. So I'm going to go ahead and move myself up out of the way here. I'm going to be like that little paper clip from Microsoft Office. So here I'm going to add a new item under PLC, and here we want a standard PLC project. So that's just going to populate some of this data here, and now I can explain what all of this means. So essentially, under system you have license. So what you would do is create a 7-day trial here, HPMIJ. So that will make my 7-day trial license, which is really nice that they let you do this. You can keep resetting this over and over again. There is no limit to it. So if you're particularly into learning on this, you can run this forever and make better and better programs. Or if you're waiting on hardware to come in that's been ordered, that's really nice because you can do a lot of your development and testing here. So otherwise, let's see, we've got this real-time tab here. We're not running at the moment, so you can't see much, but there's some settings in here with your PLC tasks and whatnot. So that determines sort of how fast your program is going to run. At the moment, it says 10 milliseconds. So every 10 milliseconds, it's going to run, which would be see, that's 100 times a second. So moving on, We'll come into, I'm going to skip tasks and stuff here. Actually, here's tasks. These are your task settings. So a cycle tick is a multiplier on your base time. So don't get too caught up on any of this stuff. It's not terribly important right now. Routes I'm going to skip because I have a bunch of routes defined at customer sites that I don't want to show. But a route is basically a link over to hardware elsewhere in your system. So if you're networked up with Ethernet, or there's some other ways to connect up, but typically these days, if you have a TCP/IP Ethernet connection up to your other systems, you can log in and do all your development right on top of them and send new code and everything. So that's all good news. Get big again here. Okay, so anyway, routes we covered. Motion, this is where your servo systems will go. This particular product, Beckhoff TwinCAT, if you get the numerical control option, will close all the servo loops right here in software on the real-time runtime that runs on your x86 processor. So it can close the loop, position loop, velocity loop, all that on a crazy amount of axes and coordinate them and do all kinds of stuff. But that's way more advanced than I'll probably even get in this entire series. So not that it's difficult, but I'm just not going into it. So anyway, here's your PLC. Come right back to that in a second. Safety, that's if you have an actual official safety system. Out of the scope of this again. C++, they will let you do some C++ code, which is kind of cool, but also not really necessary for the most part. And then your I/O. So this is where your program reaches out and actually pulls sensory data in and outputs to physical devices. So this is where stuff gets really cool, actually. But you can add USB devices of certain types. You can add a parallel port in here. You can add any field buses, which is what your I/O would normally land on. If you have local I/O on a actual physical PLC, I/O that's just snapped right onto the side of it, that would all come in here. So we're going to probably stay out of that for a while at least, and focus more on the software, on the code side of things. So I've created this PLC project. It's called Untitled at the moment, but I've got some folders here. External types, don't worry about that, you don't need it. References are libraries, so you'll get some standard libraries that have some general functions in them. You can kind of look through them and see what they offer. So let's find some easy ones. File close, file delete, file open, stuff like that. So you get kind of a base set of good functionality right out of the box with this, and then you can add in all the ones for motion control and all sorts of stuff, and you can make your own custom libraries and stuff, but that's even more advanced, so we're skipping that as well for the moment. DUT is going to be data unit types, so that's your user defined data types. I will do an episode on that later on. So global variables are anything you want to be globally accessible from all of your programs. POUs here is program organizational units. So this is the meat of your code here. It usually lands in this POU folder. Back in the old days of TwinCAT 2, these folder structures were pretty tightly enforced. But nowadays you can put any program in any folder. It's really nice, but it's also kind of scary depending on how people organize their stuff. So, but I'll keep it organized here. Visualizations are like local displays for debug displays. If you want to make like a little mini HMI, you can put that in there and talk directly to the PLC variables and so on. They're really helpful. I'll be using those to pretend I have hardware later on, so I'll touch on those a little bit, I think. And so I guess we're ready to jump into a main program. You've got your variables up here, so I can say like my boolean is a bool type, and I will jump down here and I will say my boolean equals true. And essentially I can run this code on my processor and it will turn my boolean equals true. I know that's pretty incredible, but basically this is a broader context here. So once you get to that point and you can run this, you're all good. So I will activate my configuration, see if it'll run for me. Restart in run mode. You see the little run down here. I'm going to log in, and what it's saying here, port 851 is the default port for TwinCAT 3's runtime 1. You can do up to 4 runtimes on one PLC, which is pretty cool, and you can do multiple tasks per runtime, so it's pretty crazy what you can get away with. But we're doing one task, one runtime right now, because that's all we need, really. So do I want to proceed with download? Yes. We'll go ahead and do that, and then I've got my run option up here. Start the PLC. Oh my god, it ran. So that's pretty cool. I can log out. I can say no, now I want it to be false. Log in. Oh, it says, hey, you changed something. You want to download it? Do you want to online change it, or do you just want to log back in how it was? So I want to log in with online change, and he goes, oh, now it's false. Everything's good. So you can hop on and change all your code just like that, with some limitations, but in general you can change quite a bit before it really messes up. So you can set breakpoints here, you can do all kinds of good stuff. I can stop the PLC, I can start the PLC. So that's about all I really want to cover, other than actually you can also set these. So I'm setting this actively as false, so I can either I can write them or I can force them. So if you force it, it's stuck true, although in practice I don't particularly care for this forcing of bits here. It does weird stuff. So, but anyway, that's basically the overview of this entire IDE. There's a lot more to it than that I just went over, like linking variables to I/O and all sorts of stuff. But I'll cover that in later videos. I'm going to keep this one relatively short. So let me know if you have any questions, and I'm going to move on to episode 3. Like and subscribe these videos if you like them, so I know where to put my effort in the future. Thanks.